Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, sir. Let me introduce myself. My name is Valditino Ivanov S with NRP, last NRP 117. And in this video, I'm going to give my reaction about the first hour lecture about the ship diesel engine and plans. First, we're going to talk about the diesel engine and the subsystem. On the diesel engine, it have many things. It's like many things system. It's like first like a charging system, and then a combustion system, an injection system, exhaust fuel system, and also lubrication, mechanical system, and the last is cooling system. All the part is from that system is combined in a one, which is a diesel engine. And from the engine style too, they have some the difference too. Is have like a trunk piston engine, it's like, and then a crosshead engine, and then double acting engine, anti-shifting engine, some kind of like that, and have a engine style too. It's like have star engines, like flat engines too, and V-line engines like in the car, and then inline, recline engine, double line engine. And then for like a working process for engine ship diesel engine for 4-stroke, it's like have a four step. It means like have from the power, compression, and exhaust and intake. And from the working process for 2-stroke, it just have a 2-step for injection for the engine. It's like from the power compression, and then just into the exhaust and going to out. Many ship diesel engine have types. The first type is slow speed 2-stroke. The 2-stroke is which some have not regulation but criteria. Last is like the 2-stroke engine have which 3 injection valve, and then have able to operate with HFO, which is high fuel oil, and then specific fuel oil consumption is 185, and then for exhaust temperature is 350 Celsius. And for the applications, a lot of 2-stroke engine, crosshead ship diesel engine is like have like develop many big what kind of like that, it's kind of like producing for the engines like Pan BW, Wärtsilä, and Mitsubishi, kind of like that. And then for the application of that diesel engine is like useful, literally it's used for shipping, and then specific container, and then a lot of power plant offshore, and then the main engine itself for the ship. And then for a lot of diameter for the bore is into 0.25 and to 1.08 meter. And then for the slow speed 2-stroke, have the propulsion plant, which is have a single engine direct on propeller, which is not have using gearbox, and then the propeller have a fixed propeller, FPP. And then the second one is medium speed 4-stroke for the ship diesel engine. That means is cross section of the 4-stroke in the 4 step. And then for the application of the development for the engine is like a Wachila 64 with the engine bore is 1.64 meter bore, and like the developer from the medium speed 4-stroke is switch a lot of like BW, Wärtsilä, Caterpillar, Mitsubishi, Yanmar, and Rolls-Royce Marine. It's kind of like that. And then for the application itself from the four-stroke, it's like using power generating on all ship and the offshore too. And a lot of the four-stroke is able to use it full. It's like HFO is able to use FO, and then small dimension is using the MDO2. And then for the third one is like fast speed four-stroke ship diesel engine. The fast speed is like contents in the engines like include like a turbocharger, air filter, freshwater pump, and all of them is like into the fast speed. It's like the fast speed is using like for the kind of speed, not kind of speed, but kind of speed, kind of ships, but not all, using this kind of engine. And for the developer from the fast speed, it's like Caterpillar to MTU, Pilstick, Wärtsilä, and Volvo Penta. And for the application of the fast speed, it's like propulsion in marine government boats, fast ferries, and then emergency generator, and then the onshore power station, like which is the mainly emergency genset. And for the diameter of the fast speed is like 1.13 to 1.27 meter. For the power range up to 1.3 to 10. And for the fast speed, for the fuel, it's only using MDO, marine diesel oil. And then for the lecture, the first hour lecture is going to talk about the fuel too, like the using of the efficient of the kind of diesel engine. It's like we're going to talk about the Sankey diagram, which if you using or fill up our machine, our whatever from your motorcycle, car, or anything which have some injection things, it's like a diesel engine. It's not at all using all of that fuel into the efficiency of your car or engine. It's like have many things from that fuel input at 100%. It's increased many things. It's like have a radiation from lubrication oil, jacket water, SCAF and recoil water, and exhaust gas. And then the self part from that things is only slide around 15 from 100%. It means have 15% from shaft power into the propeller, and then 50% is like from exhaust gas, SCAF, and then many things like that. And then for the yesterday, we're going to talk about the specific propulsion power too. It's like power demand from the capacity of TU capacity. And then we're going to talk about the emission, which a lot of fuel oil like air, fuel oil, and lube oil into the engine process, which have a heat and work. From that things, from the output is have a exhaust gas. And then we're going to talk about the modern diesel engine, which have emission behavior. Efficiency, effective efficiency more than 15%. That means the fuel consumption have a CO2 emission to have a few, and then a high NOx emission, and then the ratio emission. And then for the diesel engine too, the ship diesel engine are usually the mission is in the best efficiency, which a lot of the big difference between ship diesel and for on-road application same reaction kinetic and thermodynamics. I think that's all from me to reaction for our lecture from first mid. I'm sorry if my presentation or my explaining is not really really good or something. I hope you understand. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.